Hello, discrete math fans. We're going to talk about combinations now. Let's try this example. A class of 15 students is going to choose a 4-person committee to represent them. How many ways are there to choose the committee? Now, once you've chosen the 4 people on the committee, then there's not going to be any roles for the people on the committee. They're just either on the committee or not on the committee. Now, before we answer this question, let's create some new notation. We're going to make a definition. We'll let n and r be non-negative integers. R is less than or equal to n. The thing that we're defining now is this, an R combination. An R combination of a set of n elements is a subset of R of the n elements. So you're picking out R elements out of the big set. And this symbol, which we're going to read n choose R, it denotes the number of subsets of size R. Those are R combinations that can be chosen from a set of n elements. So that means the answer to the question that we asked at the start of this is 15 choose 4. But right now we don't have a way of counting this. This is a number, but we don't know what number it is. So let's ask a related but slightly different question. Now let's ask, how many ways are there to select 4 students from a class of 15? But now we're going to give them roles: president, vice president, secretary, and treasurer. How many ways are there to do this? What we're going to do is answer this question twice in 2 different ways. And since they're answering the same question, they have to be equal. Okay, answer number 1 is that this is just a 4 permutation of a 15-element set. And we know how to count that. That's P of 15 comma 4. So that's 15 factorial over 15 minus 4 factorial. Answer number 2 is we're going to make a 2-step process. In the first step, let's select the 4 students, but we won't assign them to a role. There are 15 choose 4 ways of doing this. And right now, we don't know what this quantity is, but we're close to being able to work out what it is. Step 2, once we've chosen who the 4 students are going to be, then we're going to assign roles to them. That's simply a permutation. So there are 4 factorial ways of assigning the 4 roles to the 4 students. The multiplication rule then tells us that there are 15 choose 4 times 4 factorial ways of choosing 4 students to be president, vice president, secretary, and treasurer. Well, we've just answered the question 2 different ways, so they're the same. What we claim is that 15 choose 4 times 4 factorial is equal to 15 factorial over 15 minus 4 factorial. So what you should be seeing here is that this is what we got in the first answer, this is what we got in the second answer. They're answering the same question, so they have to be equal. That lets us now solve for what 15 choose 4 is. Here's 15 choose 4. We get that it's 15 factorial over 15 minus 4 factorial times 4 factorial. And now, if you like, we can compute a number. We end up getting 1,365. Let us say, for the purpose of the doctrine of laziness, that it is okay in all cases, unless otherwise specified, to leave factorials like this in our answer. We don't need to reduce all the way to a number. So this idea is going to lead us to a general formula for counting R combinations. We'll phrase this as a theorem that says that the number of subsets of size R, or R combinations, that can be chosen from a set of n elements, we'll denote this with n choose R, is given by n choose R is equal to P of n comma R over R factorial, which is equal to n factorial divided by n minus R factorial R factorial. Everything we're doing here, R and n have to be non-negative integers, and R has to be less than or equal to n. Okay, that's all for now.